All right, hi folks. Today we're going to be solving a question from the toughest shift of JEE Mains 2025 session 2. And it's a question on circles, so it should primarily involve coordinate geometry. Let's give it a fair attempt. So you've got a circle C1 in the third quadrant, right? So the figure is going to be something like this. You know what? Let's just make use of the wonderful tool that OneNote has provided that lets us just draw the perfect circle. Okay. So this is C1, right? And it's touching both the coordinate axes. So we know that the line joining the center to the point of tangency has to be perpendicular to the tangent. So this has to be perpendicular to the axis, and so is this line going to be as well. So this is the y-axis, and this is the x-axis, and this is 3 because the radius is given to be 3. Let C2 be the circle with center 1, 3. So a circle somewhere around here, 1, 3, that touches C1 externally. So it's going to touch C1 at a point this, let's say, right? At a point alpha comma beta. So we need to compute beta minus alpha square. Call this m by m, where m and n both are like they don't have any common factor, and we just need to compute m plus n. So essentially, we need alpha and beta, right? Now, one observation that you should make straight away is at the point of contact between two circles, the line joining the center should be passing through that point, right? Because they share a common tangent at the point of touching each other, and the tangent is going to be perpendicular to both the radii. So it's going to be passing through both the radius anyways. So what we can assert over here is if we know that this point has to be minus 3 comma minus 3 purely from a geometry standpoint, like the perpendicular distance of this point from the x-axis is 3 and it's in the third quadrant, so it has to be minus 3 comma minus 3, and this is alpha comma beta. Now what's the slope of this line m, right? Like essentially this also lies on the circle C1, the point alpha comma beta which you're trying to find. And if it lies on the circle, then this distance from the center of that circle C1 is 3. So essentially we know the radial distance. If we know the angle theta over here, we can actually get the point alpha comma beta by using parametric form of a straight line. For that, we just need the slope of the line first, and we're making use of the fact that the line joining the centers also coincides with the line joining the point with the centers individually. So the slope m is going to be 3 minus minus 3 divided by 1 minus minus 3, which is just y2 minus y1 divided by x2 minus x1. So this is 6 by 4. This is 3 by 2, right? So if you have a look at this, this is going to be a triangle 3, 2, theta, and this is going to be by Pythagorean theorem root 13. So cos theta is nothing but 2 by root 13, and sine theta is nothing but 3 by root 13. Now, using parametric form of a straight line, right? We know that any point on the straight line, alpha comma beta, has to be of the point x1 plus r cos theta, comma y1 plus r sin theta. And in this case, we know x1, we know y1, we know r, we know sin theta, we know cos theta. We can literally just find alpha comma beta straight away. So our alpha comma beta is going to be x1, which is minus 3, plus r, which is 3, into cos theta, which is 2 by root 13. And your beta is going to be minus 3 plus 3 into 3 by root 13. Now you want beta minus alpha, right? Which is nothing but this whole thing minus this, which just leaves you with 3 into 3 by root 13 minus 3 into 2 by root 13, which is just 3 by root 13, correct? Now when you square this, beta minus alpha square is equal to 3 by root 13 whole square, which is nothing but 9 by 13, which is m by n, m by n. And we know that 9 and 13 have no common factor. So the GCD of 9 comma 13 and thus m comma n is equal to 1. So this is our answer. M is going to be 9, n is going to be 13. And since the question asks for m plus n, that has to be 22. So the final answer is going to be option number A, 22. Hope that makes sense.